Now we're going to do word problems with exponential and logarithmic equations and formulas. There's 19 previous videos that you can click on this description to watch any ones that you might have missed. So we've got this formula, and we've got a equals p times 1 plus r to the t power. Now, the amount a that principal p will be worth after t years, that t is for time, at interest rate r is compounded annually is given by this formula, all right? And that's a 1 plus the rate, okay? So we've got our formula, and $4,000 of principal is invested at 6% interest and yields, which means produces, $5,353. For how many years was it invested? So we take all of our information. You can see I have it nice and color-coded. We've got our 5353 that goes here for A. We've got our 4,000 that goes here for the principal. We've got our 1 plus the rate, which we write in decimal notation as 0.06, and it's to the t power. We can add the 1 plus the 0.06 and get 1.06, right? Now we just solve for t. We're going to take the log for both sides of the equation. And use the log of a product and log of a power theorems. We get log 5353 equals log 4,000 plus t times log 1.06. So, and we solve for t. So if you remember back from 12.4a and 12.4b where we talked about this log of a product, these factors become addends and this exponent gets put in front to be multiplied to the log, okay? So that's what we're going to do for this, okay? So we end up with this, and we can divide each term by this log 1.06 to eliminate it. Now we have this. We want to solve it for t, so we can take this entire guy and use additive inverses and subtract him from both sides of the equation. That makes him disappear from this side. He's eliminated. And then on this side, we get the quotient of log 5353 and log 1.06 minus, see, because that minus sign, the quotient of log 4,000 and log 1.06 is going to equal t. So now we have our t isolated. Now what we have to do is use our calculator to find the log values. And we type in log 5353 and we get 3.7286. We type in log 4,000 and get 3.6021. We have to subtract these. We have to subtract the blue one minus the red one, don't we? And we get 0.1265. It's going to be over that 0.0253. We do our division, and we find out it was 5. It was invested for 5 years. We can take that 5 and put it back into the equation as the exponent, and we can see that it's almost 5353. This 90 cents makes us round up to 5353, doesn't it? All right? Let's do this with loudness of sound. So the sensation of loudness of sound isn't proportional to the energy intensity, but instead is a logarithmic function. And loudness is measured in bells. It's named after Alexander Graham Bell. Or it's measured in smaller units, decibels, and it's abbreviated a lowercase d and a capital B. Loudness in decibels of a sound of intensity I is defined to be this formula. So we have this capital I with a little subscript 0, that is the minimum intensity detectable by the human ear. When a sound is 10 times as intense as another, its loudness is 10 decibels greater. But if a sound is 100 times as intense as another, it's louder by 20 decibels. See, it didn't go 100 times greater, it only went 20 decibels. See? So this is a logarithmic function. So a motorcycle or power saw is about 95 decibels. Rainfall is about 50 decibels, and a ticking watch is only about 20 decibels. All right, so that'll give you a rough idea of the intensity of sound. So we're going to find the loudness and density in decibels of the background noise in a radio studio for which the intensity I is 199 times that minimum intensity, okay? That initial one. So we substitute into the formula and use a calculator. So here's our formula, and we put our 199 into here, and we can see this can cancel out, can't it? So we just have 10 times the log 199. If you have a scientific calculator, you put in 10, you hit the multiplication button, you enter 199, you hit the log button, and then you hit equal, and you'll get this. We can round this off to 23 decibels. If you're using a cell phone, you're going to want to hit log first, and then 199, and then the close parentheses. Then you want to hit the multiplication and the 10, okay? And it'll give you this also, which rounds to the 23 decibels, all right? What about the loudness of a rock concert with intensity 10 to the 11th power times that minimum? Well, it can also be written like this. So if you see this, it just means 10 to the 11th power times that initial minimum intensity, okay? So put it in our formula. This cancels out, right? So now we've got this. They have the same base. This is 10 to the first power, right? So really we just have 10 times 11. It's 110 decibels, all right? So that's louder than a motorcycle. So actually for a concert, that's not too bad, is it? All right, so let's do an earthquake. The magnitude of an earthquake on the Richter scale R of intensity I is defined as this formula. And this capital I with the little subscript 0 is used as the minimum intensity for comparison. And an earthquake has intensity 4 times 10 to the 8th power times that minimum intensity. Well, this can also be written like this with the I just right next to it, okay? It means the same thing, all right? Because it's multiplying, right, when you put them together. So what is its magnitude on the Richter scale? Well, we put our information in, okay? We put this into our formula, and this is multiplication, so it can actually be written as addends, right? These cancel each other out. So we have log 4 plus log 10 to the 8th. Now, basically, we just punch this into our calculator and get our answer. Okay, so log 4 is 0.6021. If you're using a scientific calculator, you just want to hit 4, then log, then plus, then 8, then equal. If you're using your cell phone calculator, you want to hit log and then 4 and then close parentheses. Then the plus sign. And then, because we're adding, log button, then enter 10, and then hit that y to the x power, and then 8. Because you're putting it to the exponent is 8, so we need to raise it up to the 8, right? Your answer is going to appear in little light writing on the window of the phone calculator screen. If you want it to be in dark writing, you'd have to close parentheses, and hit equal. But your answer will actually turn up right here, okay? So we can add these and get 8.6021. We round this to the nearest tens place, and it's about 8.6 on the Richter scale. All right? Okay, so now we've used logarithms and formulas. Aren't you proud of yourself? It wasn't that bad, was it? All right. If you had any difficulty, you might want to go back and watch those previous videos if you've missed any or if you need to be reminded. Our next video is 12.8a, and 12.8 is going to be the end of Chapter 12. We're going to go on to Chapter 13, and then we're going to stop for Algebra II. We're going to do natural logarithms and exponential function base E. There's going to be a link to those 19 previous videos. And this entire chapter has been about exponential and logarithmic functions. So if logs are driving you crazy, go and look in this description, go back to 12.1 and start watching that first video. You watch those 19 videos, and I bet these log functions won't seem so crazy to you. All right? Keep trying. Have a great day. I think you can do this, and I'll see you next time. Bye.